Radar vision technology is a technology that's unique to SmartSensor Matrix. It enables this sensor to create an image of the intersection and of the approach to the intersection in the same way that video detection technology does this. And yet it allows the sensor to overcome many of the problems that are inherent in video detection technology. And we'll talk about these concepts a little bit more throughout my presentation. But first, to talk about video detection technology, there are a number of good reasons why we are comfortable with video detection. First of all, the image that we see from a video camera is recognizable by us humans as cars and trucks traveling on the roadway. And this image can then be brought back to a traffic operations center and can be used for traffic monitoring. A more subtle reason is that when we see a vehicle, a car, traveling along the approach to a stop bar, we know inherently that there's redundancy in that data, in that video stream. And that redundancy gives us confidence that the technology is suitable for vehicle detection. The problems with video detection, however, are well known in the industry. There's problems with glare, with shadows, and changing lighting conditions. There's the cleaning that's required for the cameras themselves. There's problems with any kind of motion or vibration of the camera. And of course, weather conditions affect the quality of the video image that's produced and will affect the detection accuracies of the sensors. So in this presentation, I'll explain how these problems are overcome by radar and how radar is able to create an image just like video is. But first, I'd like to talk about the different types of radar that are used in the marketplace. The first one I'd like to talk about is Doppler radar. Doppler radar, most of us are familiar with it because of its use in speed guns in law enforcement. So it operates on the principle of transmitting an electromagnetic wave that then bounces off of a target. If it's a moving target, then this electromagnetic wave will experience a shift in frequency, known as the Doppler shift. So the received signal then will be at a slightly different frequency than the transmitted signal. The Doppler radar device will compare these two frequencies, and the difference between them then will be proportional to the speed of the target. This makes it a good technology for measuring speed for law enforcement. It's also used in some applications where detection is needed. So any movement in a particular area will register a detection. This is often used in exit gate applications, for example, when a specific spot or specific area detection is needed in that specific area. So this is a basic type of radar. Definitely does not create any kind of an image of the traffic on the roadway. So the next type of radar that I wanted to talk about is side-fire ranging radar. And side-fire ranging radar operates on the principle of measuring the distance from the sensor itself to the traffic on the roadway, as illustrated here. And this principle of measuring the distance to the vehicles is useful in generating the traffic statistics such as counts and occupancy and classifications for each individual lane. As a vehicle passes in front of the sensor, because it knows the distance, knows the lane that that vehicle is traveling in, and is able to accumulate the statistics for that lane. SmartSensor HD is a good example of this type of a sensor. SmartSensor HD is unique in the marketplace in that it uses dual radar technology. These two radar beams are used to calculate a time delay. So as a vehicle enters the first beam and then the second beam, the sensor records that time delay and uses that to calculate a speed for the vehicle. The second reason that SmartSensor HD is unique in the marketplace is because of its use of high-definition technology. So high-definition technology is enabled by high bandwidth transmissions of the radar. These high bandwidth transmissions enable the radar to have very crisp and clean radar returns. And these distinct radar returns then contribute to the high accuracy, count accuracies of the sensor itself. So even though SmartSensor HD is unique in the marketplace in the use of dual radar technology and high definition technology, it doesn't create any kind of an image of the traffic on the roadway. So the next type of radar that I want to talk about is forward-fire ranging radar. And it works on the same principle as side-fire ranging radar, except now instead of measuring the lane that the vehicle is in, the range measurements now measure the distance of the vehicle along the approach of an intersection. So this ranging then enables the sensor to track a vehicle as it's approaching a stop bar or approaching the intersection. SmartSensor Advance is a good example of this type of radar. What makes SmartSensor Advance unique in the marketplace is its use of estimated time of arrival. So the way this works is that as the sensor measures the distance to a vehicle, it can track that changing distance and then generate a speed measurement for that vehicle. Given the distance of that vehicle or the location of that vehicle and its speed, it then can easily calculate the estimated time of arrival at the stop bar for that vehicle. This turns out to be a very useful metric for doing dilemma zone protection. Turns out that the estimated time of arrival at the stop bar is a good predictor of if a driver will be caught in the dilemma zone, the dilemma of whether he should go through the intersection or stop at the stop bar when the light transitions from green to yellow. So by generating this metric and using this metric for its detection outputs, SmartSensor Advance is able to provide more efficient and much safer dilemma zone protection than the traditional ways of doing dilemma zone protection. So even with this unique feature, SmartSensor Advance does not provide any kind of an image of the traffic or of the approach to the intersection. So that then takes us to the next sensor, and the one that does create an image of the roadway. This is a multi-beam ranging radar, and SmartSensor Matrix is the only one of those in the market. And as the illustration shows, it works on the principle of having 16 different radar beams. Each of these beams steered to a slightly different angle, and the combination of all these beams creating a 90-degree field of view. So each of these beams is used to measure the distance to the targets in front of the sensor. The illustration may imply that it's only measuring the distance to the first target. That's not the case. It actually measures the distance to all the targets that are within the field of view of the antenna beams. It makes these distance measurements 3,600 times a second out of any one of the 16 different beams. It combines all of this data, all of these range measurements from all the different beams into one image that is then used for doing traffic detection and for monitoring the vehicles as they travel along the approach. This next image that I wanted to show you, this is a picture of SmartSensor Matrix with the lid removed. And I wanted to show this because this was my piece of the development project. I designed these 16 different antennas so that each one is steered to a slightly different angle. And as you can see, each of the rows of rectangles is a separate antenna and steered to the different angles as I explained. So by using radar technology, we inherently overcome the problems with video. A radar is completely independent of lighting conditions. It does not require cleaning. It does not have problems with motion or vibration, and the reason for that is because it's range-based, it's distance-based. While there may be a slight change in distance because of a vibration of the pole, that change in distance is not significant when we're talking about the size of the detection zones and the size of the vehicles on the roadway. While overcoming the problems inherent in video, SmartSensor Matrix is able to provide an image of the roadway. It's able to track the vehicles and create representations of the vehicles, giving us the same comfort level with this detection technology that we have inherently with video. One of the first installations of SmartSensor Matrix that I was able to attend was at an intersection where one of the side streets was coming from a small residential area, a quiet residential area. And so there was very little traffic on one of the approaches. The city traffic engineer was there on site, and he was interested in learning more about SmartSensor Matrix and becoming familiar with it. We were able to set him up with a handheld device that was connected wirelessly back to the traffic cabinet and, of course, connected to the sensor from there. So he could take the handheld device and walk out on the approach of the intersection and see the detections of his own person here on the handheld device. As he walked up and down the lanes of the traffic, he could see that the detections were happening down the middle of the lanes as they were configured in SmartSensor Manager on the device itself. Being able to do this gave him quite a bit of confidence. First of all, that the sensor was configured properly, but more importantly, it gave him confidence that this was a technology that was suitable for vehicle traffic detection, because it was suitable for detecting him as a pedestrian in the roads. This was very satisfying to me as one of the developers of this technology, to see somebody who was interested in it, becoming familiar with it, and ultimately gaining confidence that this was a technology that they wanted to use in their city. I hope that you'll have a similar experience, that you'll become familiar with SmartSensor Matrix and develop confidence in it. Thank you.